Hey everyone, in this video I'm going to talk about Python multi-threading, and we're going to use it to back up network devices in parallel. Alright, so I got steps here. So step 1 is to import required modules. So we are importing pandas, netmiko to connect to the devices, datetime for the timestamp file, and ThreadPoolExecutor, and as completed from concurrent.futures and time. All right, so step 2 is we define the base class or the parent class for network devices. So this is the name of the parent class, network device, and we have the init method, and we have this method. So we can think of this method as a blueprint that will be implemented by the subclasses. And we also have this str, or dunder str, or underscore underscore str underscore underscore method, and this basically just acts as a label of the object. Okay. Step 3, this is how we define the CiscoDevice class. So this is the CiscoDevice class. CiscoDevice is the name of the class, and we are inheriting from the parent class. So we are inheriting basically the host name, right, or the init method basically. And we also have the device type attribute. Okay, so we have the backup method, right? And this is where we connect the devices, or to the device, in this case CiscoDevice or devices, and we send the command called show version. So I mentioned backup network devices, but I'm using the command show version because the routers or route servers that I'm using don't support the command Cisco version. We don't support it because we don't have the correct privileges. But in real world, if you're going to use real devices, you can, of course, use show run config, okay, to back up the configurations. And we are defining the timestamp, the file name, and we are opening the file as file, right? And we are writing the output from the show version, and we are just saying that, we are just printing this or returning this part here, meaning we have successfully backed up the config, and this is the file name, which is this file. Okay. Similarly, we have the same for the Juniper device. So we are defining a class called Juniper device, and we are inheriting this from the parent class, right? Or we are calling the super method from the parent class, and we are defining the device type, which is Juniper Junos Telnet. So we are just using Telnet to connect to the devices, by the way. And we have the same backup config method. So here we are using the show BGP summary compared to, different from show version, which is fine, right? And we are defining the timestamp, file name, right? And we are opening the file, and as write mode, with write mode, and we are writing the output from the show version, show BGP summary, and we are just returning this message here to tell us the backup or the command was successful. And step number 5 is this is where we read the device information from the CSV file using pandas, right? So what we are doing here is we are defining a list called devices, right? this is where we are going to append the device objects here. You can see here. So yeah, so this is how we load the data or the device data from the CSV file. And we are defining a data frame, which is this df. And we are just here in this for loop, we are iterating over each row in the data frame. And if the row is equal to this, so let me open the file. If the row is equal to, or if the device type is equal to Cisco IOS Telnet, we call the, we instantiate or we create this device object, which is Cisco, right? And if the device type is Juniper, we instantiate or we create this device, which is a Juniper device or object. Okay, and if it's unknown, we just skip the device type, okay, or we just skip the device. And of course, we append the device objects in this list. Okay, and step number 6, this is how we backup or send or call the methods of each objects, right? So here we are creating a ThreadPoolExecutor with 20 worker threads. And by the way, this is just an optional argument, right? You can remove this and the code will still work. Okay, and we have this now executor, right? And we are, just to explain this a bit. So here, what we are doing here is for each device object in the devices list, we submit that device using, or we schedule it using this expression here, right? So the syntax is this. So for item and iterable, which is a list in this case, and the expression here in this case is this part. And of course, all of this, we save it in a variable called futures, and this becomes a list. Okay, so the next step is iterate over futures as they finish, not in submission order. So we are saying this because we are using the function called as underscore completed, and we are passing in the futures list. And of course, for each future, we get the result. And then if we see that in the result there is a backup or a string called backup save to, we consider that as successful. So we count success count. We execute this expression here. Or else we execute this expression here, which is failure count +1. And of course, we have this try except block, right? So the except will catch any errors from the backup config. All right, and of course that will add to the count to the failure count as well. And of course we print the result. And here I have start time and end time. This is just to show us the total execution time of the script. So let me go ahead and run this code and see what happens. Backup. Okay, so the script has finished, and now we see that there is 4 successful backups and 1 failed, and the total execution time is 21.07 seconds. So this is using threading. So let me show you how long will it take if we are going to use the sequential script or not using multi-threading. So Python backup. So again, earlier it took 21, right? If I'm not mistaken, 21 seconds. Okay, so the execution time is 51.62 seconds. So yeah, so we know that using multi-threading is much faster than using a or not using it, right? So that's why we need to use multi-threading if we have a lot of devices. So in this case, we only have 5 devices, right? But what if we have 1,000 devices? So it's not practical to use the sequential backup style of doing it. So it's usually recommended to use multi-threading, which in this case we are using concurrent.futures. All right, so hopefully you found this video useful. If you did, don't forget to hit like, subscribe, and I'll see you in the next one. Bye for now.